Dear professor and faculty member, I want to present my homework about programming and microcontroller using C# and Arduino Uno to control 7-segment display in multifunction field for making counter-up. My name is Sukma.meganova FND. I'm a doctoral student in Rajamangala University of Technology, Tanyapuri. This is the outcome of my homework. A program that can counter up from 0 to 9 in 7-segment display of multifunction here and operates it in 2 different states, stop and start counting, by using graphical user interface in Visual Studio C# platform. And the picture of the experiment is shown in this slide is like this. This picture means that the experiment was successful. This is the hardware that I use in this homework. The first is Arduino Uno, multifunction shield, jumper, and cable USB to printer. And this slide, this is about wiring diagram. In this picture, this is the wiring diagram when I connected the multifunction shield into Arduino Uno. And this is the table that shows the pin that I used in the Arduino Uno that connected to the pin in multifunction shield. In this Arduino Uno, I use pin 3.34 that connected to pin IO ref in multifunction shield, and then pin reset to pin reset, another pin 3.34 connected to pin 3.34 multifunction shield, pin 5 volt to pin 5 volt, all pin ground to all pin ground multifunction shield, then pin V-in connected to pin V-in multifunction shield, and then pin A0 until pin A4 connected to the pin A0 until A4 multifunction shield. This is the software that I use in this program, in this homework. The first is Arduino Uno IDE version 2.3.2, and then the second is C# platform using Visual Studio. Then I will explain about the code in the Arduino Uno. This is the code that I made for the Arduino Uno. The first, of course, this is about the definition and declaration. From the top until this line, this is for definitions and declaration. The first, for this line, this is latch pin, clock pin, data pin, control the latch, clock, and data lines of the shift register. And for this line, the baud rate for serial communication that used in this program for communication is 9,600 bits per second. And for this part I will explain line by line. This one is for stores the character read from the serial input. And then for this line, this is a flag used to track whether the display is turned on or off. And for this is tracks the current digit to display on the 7-segment display. And the times and times 2, this is a variable used to measure the time difference between updates to the display. And for this one, this is also related with my previous videos about keypad, control the 7 segment in multifunction cell. For this line, this is whole hexadecimal value for the digit 0 until 9 for the segment. For the 7 segment display, these values control with segment light up. This number is a hexadecimal number for 0 until 9. And then for this one, this is likely used for additional configuration, possibly for controlling decimal points or status indicator. This is means the address of every segment in the 7 segment display of multifunction cell. This is segment 1, segment 2, segment 3, and segment 4. And then this is the setup function. There are pin mode, latch pin, clock pin, data pin. This is setup pins as output. And then for this line, this is initialize serial communication at 9600 baud. This one, this is second initialization is redundant as it repeats the baud rate setup. And this one, this is the loop function. I will explain one by one. This is in this line, this is for read a character from the serial input. And then for this one, this is for switch case function. The switch statement checks if the input is 1, it means to turn the display on, or 0 to turn off the display. Then in this part, and for this part, if the display is turned on, a loop runs 4 times from this line, then sending data to the shift register to display the current digit. And in this part, this is the program tracks time using millis, which returns the number of milliseconds since the program started. If 1000 milliseconds have passed from this line, the digit count is incremented. After the count reaching 9 and then reset to 0 and ensuring the display cycles from 0 to 9 repeatedly. And for this line, this is updates the time variable to track the last time the display changed. So all this Arduino program, this Arduino-based program, controls a 7-segment display using a shift register and serial communication. The program reads serial input 1 or 0 to turn the display on or off. When the display is turned on, it cycles through digits 0 to 9 every second and displays them on the 7-segment display using a predefined hexadecimal table. The program sends the selected digit to the display using the shift out function to control the shift register. And then I will explain about the program in the Visual Studio. The first, I will explain about the designer form that I made in the Visual Studio. Is shown like this. For making this design, we have to open the C# Visual Studio and then make a form design by going to Toolbox menu, go to All Windows Form, and then find the icon for the first 1A, 1B, 1C. This is icon button. For 1A, this is the button connect. This is for connect the hardware. And then in the 1B, this is the button 7 segment on. This is for turn on or start the counter up mode in 7 segment display. And then 1C, this is button 7 segment off. This is for turn off or stop the counter up mode in 7 segment display. And then number 2, this is the icon text box. This is for show the comport hardware is detected in computer. And also this one. And this one is the icon from icon label for giving a specific name. And then for this one in the bottom, we have to go to Toolbox, Components, and find the icon for number 4. This is icon serial port. This is for open and close the connection between hardware and computer. And then number 5, this is the icon of timer. This is the component that traces an event at user-defined interval. And then I will go to the Visual Studio. I will show this is the designer form that I made, and this is the program. This is a program is designed for serial communication, specifically for controlling a device via serial port using a graphical user interface or GUI. The program allows a user to connect to a serial port, send signals to turn a device on or off, and handle timers for automated control. In this line, there is system.io.port. This is particularly important for serial communication, allowing you to interact with serial ports. And for this line, system.windows.form. This is for building and managing the graphical interface of the application. And for this part, there is initialized component. This is initialize the form's graphical components like buttons and drop down. And then for this line, this is retrieves the names of all available serial ports, COM ports on the system, and adds them to a drop-down combo box so the user can select one. And then for this part, this is automatically select the first available serial port in the combo box. If no ports are available, the program sets the combo box text to unavailable. And then for this part, this is the connect button click function. There is serial port name. This is for sets the port name to the one selected from the combo box. And then for this one, the serial port.open. This is opens the selected serial port for communication. And then for this part, this is once the port is open, the turn on and turn off buttons are enabled, so the user can control the device. This part is turn on button click function, and also this one is turn off button click function. In those functions, there is serial port dot write, it means sends the character 0 or 1 over the serial port to the microcontroller. This command tells the microcontroller to turn off or on the connected device. And then when the turn on button is clicked, the program sends a one command via the serial port to turn on the device and starts a timer that triggers even every 500 milliseconds. And for this function, this part, when the turn off button is clicked, the program sends a 0 command via the serial port to turn off the device and stops the timer. So all of this C# program in the C# platform provides a graphical interface for communicating with a serial device. In this case is Arduino. It allows the user to select an available COM port, open the connection, and send commands to turn a device on or off. Clicking the turn on button sends a 1 signal via the serial port, while turn off sends a 0. A timer can be started and stopped alongside these commands. The serial communication framework is built using the serial port class in C#, enabling interaction with external devices via serial communication. I will show the experimental of my homework. This is the code or Arduino program. And then this is the Visual Studio. This is the design of form. And then this is the program. And then for running this experiment, I have to connect the hardware to the computer using cable USB to printer, and then go to the Arduino IDE, and then upload the program. Of course, you have to choose the right board and right COM port until the compiling is done, and then go to Visual Studio for running the program. Just clicking start icon, and this is the form load, same with the design. This is combo box for detect to show comport comport are detected. The show comport are detected in the computer, and then we have to check the port are detected in the computer. This is COM3. We can check from tools menu port and then check the COM port are detected. And then we are ready to click the button. The first, change the right COM port and then click button connect. And then click button 7 segment on, then the display in 7 segment will count up. 6, 7, 8, 9, and then back to 0 until 9 again, and then back to 0 again. And then when I click 7 segment off, the counter will stop at specific number. And then when I click again 7 segment on, it will continue from the last number, last counting. Then I will click this off again, then the counter up will stop, and then click on again will continue, click stop again or off will stop, the counter will stop, and then after that we have to close the running program by clicking the stop, clicking the icon stop. This is the experimental. And then this is for the summary of this homework. These programs control a 7-segment display to an Arduino and shift register using serial input from a computer. The display shows digits from 0 to 9 updating every second. The user can send one signal via serial communication to turn the display on and zero signal to turn it on. It uses the shift out function to send data to a shift register that drives the 7-segment display, and millis to control the time interval between digiting. This is all of my homework, and thank you for watching.